Okay, today's review for the upcoming assessment is going to be about the absolute value theorem. Okay, so this is going to be your study guide part 2. So make sure that you organize this in an organized way such that it's separate from that first page so you can quickly flip back and forth and find keywords. So we're going to be finding an absolute value of things today. So obviously this is going to be used to find the absolute maximum minimum of different functions. And that is really important. I'm going to box in that word absolute because if we're asked for the relative minimum or maximum, we're going to have to go back and see the first derivative test, which is a different test that tells us relative minimum and max. So for the absolute min and max, we can actually plug our critical points and endpoints into f, our original function, to get our outputs and kind of compare highest and lowest values. So remember that critical points tell us our f prime is equal to 0, okay, and our endpoints of that interval, the first and the last number. So, okay, and we're going to plug those into f, the original. So notice how the endpoints and the critical points we're getting from f prime, but we're plugging those into the original f. So let's take a look at an example. We're going to start by finding the absolute maximum and absolute minimum values for each function on the specified interval. So the very first interval that we have here is, the very first function we have here is f of x equals x to the third minus 3x squared, etc., etc. So the first thing we're going to have to do is find our critical points. So let's find where f prime equals 0 by just finding f prime to start. So 3x squared, minus 6x, and we're still talking about this interval. So once again, maybe I should annotate here, these are my endpoints. And what I'm doing here is finding my critical numbers or my critical points. So I found my derivative. I'm going to set that equal to 0 to find my critical values or my critical points. And I'm going to solve this by factoring. There's a GCF here of 3x. So that leaves us with x minus 2. And then from there, we just break up each one of these factors and set each one of those equal to 0. I'm actually going to show my steps here. And I get x equals 0 and x equals 2. So now those are our critical values. All right, so off to the side here, I'm just trying to find my critical points, my critical values, my critical numbers here, which are going to be 0 and 2. Now normally with the first derivative test, we might check to see if things are increasing or decreasing. But really what we're going to do is we're just going to save these and see if by chance those will end up being our absolute maximum and minimum. So now we're just going to go off to the side and we're going to make a table. And this table is going to look, I'll grab a different color here. The following, we've got x and let's say f of x. And we're just going to show our calculations off to the side here. So the values that we're going to plug in are going to be 0 and 2. Those are going to be our critical numbers, right? So maybe I just make an annotation to myself later when I look at these. And 1 and 4 are going to be my endpoints, right? On my interval. So these are the numbers that I'm going to plug into f of x, which is my original function, right? So that's going to be x to the third minus 3x squared. There's one thing that before I begin I should think about is, are all of these points on this interval from 1 to 4? Well, one of these doesn't belong here. Even though this is following the process, I have to make sure that it's on the interval specified, so from 1 to 4, and actually 0 is not in that interval of 1 to 4. So even though it was a critical point, they really said on the specified interval from 1 to 4, so even though it was a critical point but not in that interval, I'm not going to plug it in. So really I just have 3 things to plug in here, 2, 1, and 4, into the original equation. So I have 2 to the third minus 3 times 2 squared. That's going to give me 8 minus 3 times 4, or 8 minus 12, which is negative 4. Now I'm going to plug in 1, and I get 1 to the third minus 3 times 1 squared. And I get 1 minus, well, that's just 3 times 1, which is negative 2. And then I'm going to do the same thing for 4. Oh, heavens me. and I'm going to get, let's see if I could remember what I was supposed to write there. That was 4 to the third power, which is going to be 16 times 4, which is 64, minus 3 times 16. This one is going to be 64 minus 48. So that gives us, let's see, 16. Alright, so now I've got all of my output values. So now I can actually determine which ones are my max and which one are my min values. So just look for the greatest and the least. So I can see that -2 is my smallest number, that's going to be my min, and 16 is my largest number, that's going to be my max. So if I were to just write a sentence really quickly, we have a minimum of -4 at x equals 2, and we have a max of 16 at x equals 4. Okay, now that's kind of our process. So if you were to review this on your own, you would just be thinking about what steps did I take? Why did I, or basically how did I get the 0 and 2? That was finding my critical points. I plugged those in. But why didn't I plug in 0? That was not on interval. So that was not on the interval 1 to 4. If that interval was like 0, 4, then absolutely I would plug in 0. So this is kind of like a special exception in this one problem. Not always going to be the case. So then I plug those in once again to my original function to find out what their outputs would be, and that helped me to find the absolute minimum and maximum. Remember, this is different than the first derivative test. If you're looking for relative min or max, see the first derivative test. Thank you.